Hello and welcome, I'm your Code Monkey. In this lecture we're going to build a proper delivery manager that will generate recipes that the customers are ordering and validate to see if the player made the right dishes. Alright, so right now we have the player capable of making dishes. So for example, I can put some cheese, cook some meat, cut the cheese, and then pick up both of them. Then let's say pick up some bread, and there you go, got a nice cheeseburger and deliver it. Okay, so that works, but right now they just vanish on the delivery counter. So there's no recipe we need to follow, no validation, none of that. So let's add both those things. Okay, first of all, let's make our script. So let's create a brand new C# script for the delivery manager. Let's make a new game object to run it. So a new delivery manager, attach the script. Let's make sure to keep things clean, so reset the transform. And also, by the way, since we're here, let's go ahead and put the plates and delivery counter inside the counter so everything is nice and organized. Okay, great. So let's open up this script. Now here, basically we need to define some sort of list to store all of the recipes that the customers are waiting for, which of course begs the question, what type is that going to be? Now, technically, one thing we could do, since a recipe is really just a list of kitchen objects, over here we could have a list of kitchen object. This would be our recipe list. Technically that would work, but that really looks quite dirty. Instead of having a list of a list, we should probably have a proper type for this. So let's write some good clean code and define a proper recipe scriptable object. Back in Unity, let's go inside the scriptable objects folder and create a brand new one. Let's call this the recipe SO. And over here, let's make this a scriptable object. So extend scriptable object, make the create asset menu. And over here for the fields, for the data that we need. Really, like I said, a recipe is just a list of ingredients. So just a list of kitchen object SO for the kitchen object SO list. Okay, that's it. That's really all the data that we need to define a recipe. Just to be able to identify them for the player, let's also add a public string for the recipe name. So just a nice name string. Okay, great. Now back in the editor, let's define. So let's go inside the scriptable objects and make a brand new one for our recipe SO. And now inside, let's create a brand new recipe SO. For this one, let's call it just burger. And over here, first of all, for the name, just name it burger. And then for the kitchen object list, well, to make a burger, first let's add some meat. And we want some cooked meat. We don't want to serve uncooked or burnt meat, so only the cooked meat. Then for a simple burger, obviously we need some bread, and that's about it. So some bread, some meat, that's our very basic burger. Now let's also make another one, so let's duplicate this one and name this one the cheeseburger. Over here, let's name it cheeseburger. And like name implies, has bread, meat, and obviously some nice cheese slices. So there you go. Okay, we have a cheeseburger. Now let's also make a mega burger, so something with everything. So let's call this one the mega burger. And over here for the string name for the mega burger. And for that we have meat, bread, cheese. Let's also have some nice cabbage slices and also some tomato slices. Alright, that's our mega burger with everything. And finally, let's also make just a nice simple salad. So let's duplicate this for a salad. Let's name it salad. And for the salad, we don't have any meat, we don't have any bread, and also no cheese. So just cabbage slice and tomato slice. That's a simple salad. Okay, so here we have all of our recipes. So back here on the delivery manager script, instead of making a list of game object, let's just make a list of recipe. Recipe SO and name it the recipe SO list. This is where we're going to place the recipes that the customers are waiting for. So let's actually rename this. Let's put it waiting recipe list, okay? So the customers are waiting for whatever is inside this list. And now we could make this a serialized field and set it in the editor, but we don't want to have a fixed list. We want to periodically spawn new recipes. And in order to spawn new recipes, we also need to know which ones we can spawn. So for that, we could add a list of all of the recipes. Then we could pick a random one from the list and add it over here to the waiting list. That would work, that's one good approach. But since we already did something similar to that various times in this course, here let me teach you a different approach that sometimes might make more sense. For that second approach, we just need one thing. We need a scriptable object to hold all of our recipes. So let's do that. Let's do a brand new C# script. This is the recipe list scriptable object. And then inside, this one is going to be a scriptable object. Let's add the create asset menu. And inside, we're just going to have a list of recipe SO. For the recipe SO list. So that's it, super simple. Now let's just create one object of this type. We can put it inside the recipe SO list since we're only going to have one. So let's make a recipe list SO, name it the recipe list SO. And then over here, let's just drag our recipes. So we've got a burger, a cheeseburger, we have a mega burger, and finally a salad. Okay, so basically we have a scriptable object with all of our recipes. And now, just for safety, since we only want to ever have a single one of these objects, a recipe list SO, for this one we can go back here in the script and simply comment out the create asset menu. So now back in the game, over here we can no longer create another type of recipe list SO. So just a nice safety thing, since we probably only need just one. And let's also add an underscore, just so it shows up at the top of the list. Okay, great. So we have this, and now over here on the recipe manager, we can basically expose that in a serialized field. So let's make a serialized field, make it private of type recipe SO list, recipe list SO, for the recipe list SO. And now here in the editor, we just drag that reference. All right, that's it. So basically the difference that we did with this method is over here on delivery manager, instead of having a list of all of our recipes, we just have a reference to one object, and then that object holds a list of all the recipes. In this specific use case, like I said, this approach doesn't really have many benefits compared to just storing the list here. But let's say we had another script that also needed a list of all of our recipes. If we did that, we would basically have duplicate references. So this script would have a list of all the recipes, then some other script would also have a list of all the recipes. And then if you wanted to add a brand new recipe, you would need to add it to all the lists on all the scripts. Whereas like this, any script that needs to know about all of the recipes just needs a reference to the recipe list SO, and whenever we want to add or remove a recipe, we just need to update this one object and everything works perfectly. That's one of the benefits of this approach, where you have a scriptable object to hold a list of all of the objects of some type. Personally, I find this pattern to be quite useful. Okay, so on Delivery Manager, we have a list of all of our recipes. Now let's just make a simple timer to spawn them. Like I mentioned previously in the spawn plate logic, you could just use a coroutine if you like that. Coroutines can be useful for running timers, but personally, like I mentioned, I do not like coroutines. I don't like the pattern they force you to use. So over here, I'm just going to make a simple float timer. So a private float for the spawn recipe timer, and another one for the recipe timer max, and let's say 4 seconds. Then we just do a simple private void update. On update, let's count down the timer, so time.delta time. And if the spawn timer is under 0f, let's reset the timer. And now let's basically spawn a recipe. So for that, let's grab a random one from the list. So we go into the recipe list SO and grab the recipe SO list. Then we're going to grab a random one. So let's get a random index. So random.range between 0 and the recipe list SO dot recipe SO list dot count. So you get a random one. This is going to be a recipe SO for the waiting recipe SO. And then we simply go into the waiting recipe SO list and we add a brand new recipe. Okay, that's it. Super simple. Let's just make sure to initialize the list. So let's do here a simple awake for the waiting recipe SO list and just initialize it. Okay, so like this, it should be working. However, we're also going to generate recipes nonstop. We don't want that, so let's define some kind of maximum. So let's define a simple int for the waiting recipes max. Let's say we can have a maximum of 4 recipes waiting. And then down here when the timer elapses, so if the waiting recipe SO list.count, if it is under the maximum, then we generate and add it. Okay, that's it, pretty simple. Now for testing, let's just add a log here to print the name. So debug.log on the waiting recipe SO that we generate. So let's print out the recipe name. Okay, so let's test. So here we are, and yep, one was spawned right away. So we have a salad, and after 4 seconds, yep, there you go, another salad. And if we wait for 4 seconds, we should have another one. There you go, a mega burger recipe. And finally, after 4 seconds, we have another burger. And now, no matter how much time passes, there should be no more since we're at the limit. And yep, time passed and no more. Okay, all right, awesome. So we are correctly generating recipes that the customers are waiting for. Now let's add logic to try to fulfill these orders. So over here on Delivery Manager, let's make a function to deliver a recipe. So let's make a public void, make it public since we're going to access this from the delivery counter. Call it deliver recipe. And the recipes are going to be delivered whilst on a plate. So let's receive a parameter of type plate kitchen object. And over here, the logic is actually going to be pretty simple. We just need to cycle through all of the recipes that the customers are waiting for and see if the ingredients on this plate matches the ones on any waiting recipe. So over here, let's cycle through all of our recipes. So let's do a for int I at 0, going through the entire recipe list.count, I++, okay. Let's grab the recipe SO for the waiting recipe SO. And we grab from the waiting recipe SO list on this index, okay. So we have that. Then first, let's do a quick test just to check if the waiting recipe has the same number of ingredients as there are on the plate. If not, then we already know that it's not valid. So over here, let's do a quick test. So waiting recipe SO, let's check the kitchen object SO list.count. If this one matches the plate kitchen object, let's get the kitchen object SO list and also check the count. So over here, we know that has the same number of ingredients. So this is the first check. Then we need to cycle through all of the ingredients on this recipe and all of the ingredients on the plate and basically see if both of them match. So let's first cycle through the ingredients on the recipe. So for each kitchen object SO, let's call it the recipe kitchen object SO in the waiting recipe. So let's go into the waiting recipe and get the kitchen object list. Okay, so here we are cycling through all ingredients in the recipe. Then we need to cycle through all of the ingredients on the plate. So let's do another cycle for the plate kitchen object SO. And we're going to go inside the plate kitchen object, get the kitchen object SO list like this. So here we are cycling through all the ingredients on the plate. Okay, so now here basically we need to see if this ingredient that we're cycling through, if this one matches the ingredient on the recipe. So here we check if the plate kitchen object SO, if this one matches the recipe kitchen object SO. If so, then the ingredient does match. So in order to keep track if it does match, over here before we cycle through all the ones on the plate, let's define a bool for found or ingredient found. Let's default it to false. And over here, if we have a match, then this one becomes true. And by the way, over here, we can also break out of the cycle. Now, if you're not familiar with break, basically this is going to break out of the for each. So let's say the plate has 10 ingredients and the second one matches. When this cycle gets to the second one, it triggers a break, so it no longer goes through the remaining 8. So basically it breaks out of the cycle, so it keeps writing some code right down here. Okay, so we cycle through all of the ones on the recipe. Then we cycle through the plate, and if we do find that ingredient on that plate, then we have an ingredient found. So over here, if we have a not ingredient found, then over here that means this recipe ingredient was not found on the plate. So if that happens, then essentially over here we have a fail state. So the ingredient that this recipe requires is not on the plate. So let's go up here when we have the same number of ingredients. Let's define a boolean called the plate contents matches recipe. Let's default it to true. And over here, if we don't find at least one of them, then the plate contents do not match the recipe. And afterwards, we can check this bool again. So if this one is true, that means they all match. If just one of them does not match, then this one won't be false. So over here, we know player delivered the correct recipe. So over here, let's do a quick debug.log and print out a message. And after we do, let's also do a return so we stop the rest of the execution. So basically, if we find a waiting recipe that matches, we don't want to keep going. And also here, if we do find it, let's also remove it from the list. So let's go into waiting queue, remove at, and remove at this index. Okay, so we're going to remove this recipe. But if this doesn't happen, then it's going to keep cycling, and it's going to cycle through all the recipes. So basically, if it reaches the end of this for, then basically no match is found. So the player did not deliver a correct recipe. So let's do another debug.log in here. Okay, so this is all of our logic. It looks a bit complex, but I hope this was easy to follow. When we see it in action, it all becomes a bit more clear. So all that's left is just calling this function from the delivery counter, so let's do that. Over here on the delivery counter, it accepts plates, it destroys plates, but before we destroy, let's go into the delivery manager, which means we need to access a reference. So again, we could add a serialized field, or in this case, it makes perfect sense to make this a singleton. So let's make it here, public static of type delivery manager, call it instance with a public get and a private set. Okay, then over here on awake, let's set instance equals this. All right, so now over here on the delivery counter, we can go into the delivery manager, access the instance, and deliver our recipe and pass in the plate kitchen object. Okay, that should do it. Let's test. All right, so let's look in the log to see what they are waiting for. So there are 2 cheeseburgers waiting, another mega burger, and a cheeseburger. So let's make a cheeseburger to deliver. So first of all, let's cook some meat. Let's slice some cheese. Let's pick up the meat before it burns, pick up the cheese, and we just need the bread. Okay, this is a valid cheeseburger, so let's deliver it. And if there you go, the player delivered the correct recipe. Okay, great. Now let's deliver something that nobody asked for. Let's say just some meat. Actually, let's burn it, just for fun. Alright, so there we have a bunch of charred meat, so nobody really wants this. But if we deliver, yep, there you go, player did not deliver a correct recipe. Alright, awesome, so over here everything worked. We have a bunch of recipes being generated. And then we have the logic so that when the player delivers something, it checks if the player delivered something correct or incorrect. So everything is great. All that's missing is obviously some nice UI, so let's do that in the next lecture.